That brings me to the last service I want to talk about, which is SQL. Sometimes it's called SQL. I prefer pronouncing it SQL. SQL stands for Structured Query Language, and it's used to store data in a database. And actually, the way that you interact with that database is you use queries, or basically commands, that can search different parts of that database. The way the data is actually stored is in tables or a set of rows and columns, and each database can contain a bunch of different tables, and each of those tables, of course, has a row and a column associated with it. There are also other kinds of databases called NoSQL databases that also store data, but they're a little different than SQL in that they don't have a set number of rows and columns. There are also other differences between SQL and NoSQL that I'm not really going to talk about. For the most part, you're most likely to see an SQL database being used. As I mentioned, there are a few different variations of SQL. I'm going to be, in this example, showing one of the more popular ones, which is MySQL. Actually, I'm running that. The actual service that I'm going to be running, which you'll see in a second on Debian, is MariaDB, which uses MySQL. However, if you're using a different kind of SQL, the only difference will be that the actual commands that, or queries, I should say, that you issue to that SQL server will be different. That'll make more sense when I go ahead and show it. But for now, I actually have a MariaDB MySQL server running on the target on port 3306. So I'm going to go ahead and scan it just like I've scanned all those other ports. And you'll notice we got back that 3306 is open. It's running MySQL. The actual version is MySQL 5.5.5. You'll notice that the service name is MariaDB in this case. So now that that's running, how can I actually connect to it? Well, the default configuration of most of these databases, including MariaDB, is that you can't access it remotely. However, it could be misconfigured, and I actually went ahead and I misconfigured MariaDB so that I actually can access it remotely. Despite being able to access it remotely, I still need to provide a username and a password. This username and password doesn't necessarily correspond with the username and password of actual machine users. So like when we were taking a look at SMTP, when we were taking a look at FTP, we were using usernames and passwords for actual users on the target. But SQL actually has a separate set of users that manage specifically the SQL service. The root user of MySQL is named root, but it doesn't necessarily have the same password as the root user on your Linux machine. I just want to make that super clear. So if you are ever curious how to connect to an SQL server, you can always consult my Red Team manual. And then on the side, if you go down to SQL, I have how to interact with all of the most common SQL variants that you're going to find. So this is how you would connect to a MySQL server. This is how you connect to a PostgreSQL server. And this is how you would connect to an MS SQL server. In this case, I'm going to be using this command right here. So in order to connect to this MySQL server remotely, I'm going to type in MySQL. Then I'm going to say -H for the target or the host that we're connecting to. That's 10.0.0.11. Then I have to specify a username. In this case, I'm going to say user root. And then I have to specify a password. I could try a variety of different passwords. So if I know that the root user on the machine, if I know that their actual password is ABC123, you might think to try ABC123. That apparently did not work. We get access denied. Another thing that if you learn about MySQL servers, you know that the default root password is actually blank. So by default, if you just set it up and you don't change anything, you can actually log in via root without providing a password. So I'm going to try that as well. And when it asks me to enter a password, again, I'm just going to select enter. And you'll notice that that actually got us in to the database. Keep in mind that this command prompt that I have here allows me to enter SQL queries so that I can actually query the database, not actual commands on the target. We're going to have to work a little bit harder if we want to be able to enter actual commands or gain our initial access. Any one of those password attacks that we talked about before, so whether that's credential stuffing or password spraying or brute forcing, that's also fair game for MySQL. And because it uses different username and password combinations, it's probably worth an attacker's time to also try those password attacks against the MySQL service if they see that it is in fact accessible remotely. Anyway, now that we've gotten in, one of the things we can do as an attacker is try to dump the databases that we have access to and see what data is in those databases. Perhaps by doing that, we can actually find sensitive information such as users for a particular website. In order to help me out, I actually don't have these SQL queries memorized off the top of my head. What I like to do is I like to go online, and there's this cheat sheet that I like to use is provided by Pentest Monkey. So if you look up Pentest Monkey, all one word, and then you type in, let's say, MySQL, right away you'll get this MySQL SQL injection cheat sheet. And even though we're not necessarily performing SQL injection in the traditional sense, that's actually a way of injecting SQL into a web application. So here we're actually just accessing that SQL database directly. However, the commands are the same. So for example, if I want to list the users on this MySQL server, I can say select user from mysql.user. So let's try that. Select user from mysql.user. And now we have a list of all of the users that are in this database, right? So we actually, interestingly enough, here we have two separate root users. It's probably an error on my part when I was configuring this. But we also have this MySQL user, and we have this MariaDB.sys user. These are kind of just built-in users. If an administrator wanted, they could create more users that have a limited set of privileges over different databases. Another thing we could do is we could run any of these commands to see the privileges that maybe a specific user has. We can also list password hashes for each of these users if we have the correct permissions. Because we actually got in as root, we do have permissions to do everything, so we can actually list password hashes. So we can say select host user password from mysql.user. Select host user password from mysql.user. There we go. And you'll see that the root user here actually doesn't have a password. If they did have a password, which would be stored as a hash, we could always go ahead and we could try to get the original password from that hash, and then we could log in as that other user. So if you're familiar with how passwords are stored in Linux, this is just kind of a friendly reminder. Passwords are not actually stored as passwords, so that as an attacker, if we gain access like this, we don't just automatically have a user's password. Passwords are actually stored in the form of a hash. A hash is a one-way function that converts passwords to some garbled text, but that garbled text can't be converted back to the original password. So what we as attackers do is perform a hash cracking attack, where we actually try a bunch of different passwords, we convert them to hashes, and we see if those hashes match. And if those hashes do match, then we know we found the original password. When you're actually logging into the application, that's kind of what it does. It actually takes the password that you provide it with, it converts it to a hash, it compares the hashes, and if those hashes are the same, then that application knows that you entered the correct password, and it will log you in. Anyway, it looks like we didn't get any more username and password information out of just listing the database users, right? But we can also actually list the information in individual databases, and that might also contain username and password combinations for the website itself. Perhaps the website is grabbing the data from the database, it's grabbing those username and passwords from the database, like I mentioned before, in which case we'd be able to read those if we have access to the database. So we can actually list our databases that we have access to with select schema name from information schema.schemata. So that's a long one, but we'll do select schema name from information schema.schemata. Sorry. And if we run that, we see that we have a few different databases. We have information schema, MySQL, sys, and performance schema. If you were to actually go ahead and look this up, you would realize that these are not custom databases. These are built-in databases that came with MySQL, so they don't really seem that interesting. Hopefully, if this database was actually being used by a web server or being used by some sort of web application, we'd see a custom one here that then we can go and further investigate. If I wanted to actually know how to find the columns in that database and then find the tables in that database, find the columns in that table, then find the rows, and then actually dump the data. That's all here, all on this cheat sheet. So here we have list tables. Then we might want to list columns. Then we want to maybe select a certain row and list the data, right? And so basically with these different commands, we can dump the database and we can find potentially interesting information as attackers. The other thing we can do, so we've reached kind of a dead end here where we can't really, there's no username or password, or there's no sensitive information that we could find in this database. But the other thing we can do with MySQL specifically is we can actually write to files. Now, by default, we'll write to files as the user that's running this SQL server. So by default, if you just set it up as is, the user that's running this SQL server is going to be MySQL. It's going to be a separate user on Linux. However, if the SQL server is misconfigured, and let's say it's running under the root user, then that means you can write to any file on the file system. Knowing that, we have to select some sort of path that we can actually write to. So in my case, I already know, because I've already looked at the environment in advance, but as an attacker, we'd have to play around with it. I already know that I can actually write to the root web directory. So I can write to var www.html. And why is that interesting? Well, if I can actually write to a file in var www.html, I can actually throw a backdoor in there that then I can use to gain access to the machine. So if this is confusing for you, just bear with me. I'm going to showcase the attack. We're going to showcase how we actually hunt for it. And hopefully when you look at how to find the attack, you'll at least understand how to go about finding and securing against the attack, right? But for now, just to show that off, the way we actually write to files in MySQL is with select, then whatever we want to write, and then we can say into OUTFILE, and then where we want to write it to. So I want to write this to var www.html, and let's say I'll call the file, I don't know, like test.php or something. Or actually, we can name it backdoor.php. And now the actual backdoor the actual contents of that backdoor are going to look something like this. So what is this code here doing? Well, because it's enclosed in this starting PHP question mark PHP, and it ends with this question mark, not caret actually, greater than symbol, less than symbol, whatever you want to call it, because it starts and ends with these characters. That tells the web server, when it's reading the code, that there's actually going to be PHP code inside here, right? System is a function available in PHP that runs basically the command that you provide to it. So whatever we provide inside these parentheses, system is just going to go ahead and run that command on Linux. Then from there, we're using $_get, which is a way in PHP to actually grab a parameter from the request that was sent. So when we actually send our request, when we request this file, which in this case is test.php, as one of the parameters, and I'll show you how to add that in a second, we're going to say cmd and equals, and then whatever we want that command to equal. This code will basically, this $_get will basically look for cmd. It'll pull the value of that parameter, and then because it's inside these parentheses, it's going to run system, and it's going to run it as a system command. So, putting that all together, again, if that doesn't make complete sense, we're going to be talking more about backdooring when we get to persistence. But for now, what we're doing is we're writing this really basic backdoor into var www html backdoor.php. And if we do have the correct permissions to do that, then when I run this, it should tell us that that query ran successfully. Okay, but why is this important? Well, now that we uploaded that backdoor, we can actually access it through our web application. So now I'm going to go back to my web browser, and now I should be able to access that backdoor, backdoor.php here. So if I look for backdoor.php, you'll notice that it doesn't give us that error message that the page was not found. Instead, it just prints back nothing. But if I add a parameter to that GET request, and remember we named the parameter cmd, and I can then say equals and give it a value, and I'm just going to use any old Linux command, like for example, who am I? And you'll notice that we get back that we are www data. So this basically means that as an attacker, we have full access to this machine here, and we can list out files and we can move around. And so we've gained our initial foothold. And the way we did that is through a combination of taking advantage of SQL, using that to plant a backdoor, and then running that backdoor through the web application. So this isn't very useful. Here I have to enter commands up here, and I have to actually send that over HTTP as a request. That's a little bit annoying. I would prefer to have an actual terminal, interactive terminal session running. And so I can upgrade this to a terminal session, and I'll show you how to do that really quick right now. So I'm going to create a listener. If you don't fully understand what I'm doing here, again, not the end of the world. I am going through this kind of fast, but hopefully you'll be able to at least appreciate the offensive side of it, and then when we take a look at defense, it'll make more sense. And so I'm going to start a reverse listener using netcat, and I'm going to listen on port, let's say 443. While that's listening, I'm going to go back here, and I'm actually going to run a command here that's going to cause the target to connect back to us on the port that we're listening on. In order to help out with that, I'm actually going to go to a site called RevShells. I believe it's revshells.com, but I could be wrong. And I like RevShells because it provides an easy way of generating a bunch of reverse one-line commands or reverse shells that you can run. So I just have to enter my IP and port because this code is going to get actually sent over to the victim, and then it's going to connect back to us. It has to know how to connect back to us. That's fundamentally how a reverse shell works. So I know that my IP address is 10.0.0.12. The port I want to connect back on is the same as the port I'm listening on, which is 443. And here I'll just use bin bash, for example. And so I have this one-line code here. I can copy that. I can throw that in here, and I can run that. And what this code is going to do is it's going to then cause the target to connect back to us. Ideally, if this worked, the web application would hang. Unfortunately, it didn't, so that means this didn't work. Why didn't it work? Well, because in the URL, we have some special characters, like, for example, spaces, that it doesn't know how to handle. And so we have to do something else known as URL encoding this data, and that basically just means that we can pass it in here in the request, and then a HTTP server will know how to handle it. So in order to URL encode, I like to go to CyberChef, and I just searched it on Google, opened up CyberChef, and CyberChef is a really easy way to convert some input to some other output in a different form. And one of those forms is, if I paste my input here, I can actually URL encode it. So if I look for URL encode, I'm going to throw that in there. And now I'm going to grab the output here, which is basically the same thing that we had up here, but it's encoded in a way that the web application will understand it. Boom. If I try running that. Skipping ahead in this video, I actually had to play around with this a little bit to get it to work. So the first thing I noticed is that bash is actually located at user bin bash. And the reason I found that out is because I used the command which. So I said which bash. That told me that it's actually located here. The other thing I noticed is if I just run this directly, it doesn't work. But if I run user bin bash -c, and then I pass that in, it does work. All sorts of little tricks that you kind of get used to playing around with when you actually get into being an attacker. But the point is that I was able to grab this reverse shell from rev shells. I was able to then URL encode it. And then when I threw that in here and I ran it, now you can see that the page is not responding to us. So that's a very good indicator that we got a shell back. And now if I go back to my netcat that I have running here, you'll notice that it logged us in to the machine as www data. So now I have a full-on interactive session. I can use this like you normally would, and as an attacker, I can go from there. Taking a look at this from the defense's perspective, now let's look at the network traffic that that attack generated. So you can see a lot of requests to this backdoor.php file with different kinds of parameters, right? Or I should say with that CMD parameter given different values. So for example, taking a look at this one, if I right-click, follow HTTP stream, you'll notice that somebody reached out to backdoor.php with this question mark CMD equals, and then it looks like they have this line that says bin bash, right? And so there you can see us actually making use of that backdoor to run various commands. Again, I can employ a trick that I showcased earlier where I search for common commands that an attacker might run. So I'm going to say edit find packet, and I'm going to look for something like who am I, right? And we actually find, if we keep searching, we find a few different instances where the who am I command was run. So the first one is here. If you remember, the first time that we actually checked if our backdoor was working, we ran who am I to test it. So we can see that right here, where we have a GET request to backdoor.php with this parameter CMD set to who am I, right? And then from there, we can see it that who am I command was run again here. So if I right-click, follow the TCP stream, this actually shows the back and forth that we had when we were able to gain initial access. So here you can see all the commands that the attacker entered: ls, who am I, ls, pwd, and you can see what the victim printed in response. So actually that full shell that we were working with as an attacker can be viewed in the network traffic. That's why it's really important to monitor that network traffic and look for potential indicators of compromise, like running the whoami command, and then you can see the full back and forth that the attacker had with the victim machine. The other thing that we might want to search for is, well, we know as an attacker that web shell that when we were using it in a web browser was a little bit annoying, and we wanted to upgrade that to a full-on session, right? But in order to do that, we had to actually run bash. And so another search string that we could look for potentially is bash. And if we look for bash, we can see right here by following this HTTP stream that here's evidence of an attacker trying to run bin bash. An attacker may not necessarily run bash, they might use one of those other options. So if I actually go back to revshells.com, I have a lot of different options that I could try. For example, I could try to use netcat on the target instead. And so, but you can search for things like bash, search for things like netcat. Anyway, point is we can try different search queries to potentially narrow down our traffic and find evidence of an attacker getting in. Again, if I take a look at the log files now, so I'm going to switch back to root here. I'm going to change directory to var log apache2, and I'm going to print out my access.log. You'll notice that we can see those requests also in the logs. And because that command was entered as a parameter, we can actually see the full command that was entered there. So we see this get request to backdoor.php with the cmd parameter and the value set to user bin bash, and that eventually got us as attackers our full session. So the same way that I search the network traffic, I can also search this log file. And because this log file is generally going to be a lot smaller than all the traffic that is being generated, the searches might go a little bit faster. So if I search, for example, for bash, right away we find the backdoor.php being called with user bin bash. And since I used grep-n, I can get the line number. I can say sudo nano plus the line number to jump directly to that line. That jumps me directly to that line, and I can see what else the attacker entered before they actually got access. So you see a lot of different calls to backdoor. You can see all of the commands that the attacker ran in order, right? So here's that whoami, here's ls, here's me trying the first bin bash, that didn't work, so I tried a bunch of other ones, and then eventually the last one got me a full interactive session. How do we actually go about fixing this vulnerability? Well, there are two parts to it. So the first thing we did is we got in through SQL and we uploaded this backdoor. So the most direct fix is removing that backdoor. So as defenders, we can go to var www.html. We can look for that backdoor, which we saw was called backdoor.php. And we can take a look at what it does. Because let's say this is a legitimate file, attackers could also hide these backdoors in legitimate files, so we don't want to just go and remove it if we don't know entirely what it does. But looking at this file, we can kind of tell that this is nothing but a backdoor, so we can go ahead and remove it. If I say rm backdoor.php, it's gone. But just disabling that backdoor that we found or getting rid of it is not enough, because we don't know how the attacker actually put it there in the first place. And that's something I see a lot as a red team volunteer for the CCDC, that teams will remove the backdoor that I put there, but then I can just put it back. So you really want to take a look at how that backdoor got there in the first place. And so going back to Wireshark, we know the contents of that backdoor. So somehow the attacker had to write the contents, so that PHP system get CMD, they had to actually write that to the backdoor. So we can actually search our packet bytes, and we can search for that string. Let's say we search for the word system, which seems pretty unusual, or something that we're unlikely to find anywhere else. And if I search through this traffic, it takes us directly to this MySQL packet right here. And by right-clicking, saying follow TCP stream, I can actually see that through SQL, here are the commands that the attacker ran. So it is a little uglier to look at this because it's not all on separate lines, but the red is what the attacker ran and the blue is what the server responded with. As you can see, they ran select user from MySQL user. That was us listing the users. Then they listed the passwords for the MySQL users. But then at the end here, we see this select, then the actual contents of that file, INTO OUTFILE, and then that backdoor.php file. So by digging through our network traffic, we could actually find how the attacker got into our, how they actually uploaded that backdoor in the first place. So now we can go back and figure out different ways of stopping the attacker from re-uploading that backdoor. The other thing to keep in mind is look at the permissions for the web root. And I actually have it set so the MySQL user can write to the web root directory, right? As you can see here, we have the MySQL group has write access to this directory. So that's what allowed that SQL user to write here in the first place. It's very important that your web files are not writable by other users unless they absolutely need to be. So in order to change this, I can actually say sudo chown root the current directory, and I can reference that with a dot. And then sudo chmod, and we'll just do 755 dot. And now if I list that again, now you can see that root is the owner of this directory, and nobody else has permissions to modify the files in this directory except root. The third thing we probably want to go ahead and do is we want to make sure that our SQL database is not accessible remotely. And we can change that in the MariaDB configuration files. So if I go to etc MariaDB, actually it's etc MySQL, I list out the files here. We see that we have this main file mariadb.conf, and then we also have a conf.d directory that's probably going to contain additional configurations. Somewhere in here I expect it to define the IP address that it listens on. If you didn't know where that was, you could always go ahead and you could look it up, or you could dig through the configuration files. Let's say I go to conf.d, I look what's in here, we have this mysql.cnf. I'm just kind of guessing right now. I don't know exactly where this is going to be. I don't remember. Apparently it's not there. If you're ever not sure where a configuration option is, here's another command that I like to use that will recursively search the contents of files in a specific directory. So if I want to search for the word listen, I don't necessarily know what file it's in, but I know it's going to be in one of the files in here. I can say grep-H horn, the search term. So in this case, I'm going to search for like listen IP, I think it's called, if I remember correctly. And then this directory, which is etc MySQL. And that's going to search all the files in this directory for listen IP. Apparently it didn't find it, so I'm just going to try IP by itself. And there are a few files here. So it looks like line 10 of mariadb.conf or .cnf. Oh, actually, I think it's going to be here. So let's go mariadb.conf.d, and it looks like 50 server, so 50 server.cnf. And then from here, here we have a bind address. So instead of 0000, which is going to listen remotely, we can change this to 127.0.0.1. This is my loopback address, so it'll only listen locally. Control O, exit that. Since we made a change to a configuration file, we're going to have to reload it. So sudo systemctl restart, probably MySQL. Correct. I actually didn't need to use sudo because I'm already the root user, but I'm just used to typing in sudo. If I do systemctl status MySQL, you'll see it's running. And now if I go back to my attacking machine, I'm going to go back and I'm going to try to get into that SQL database again, the same way I did before. And this time when I try it, it instead sends me an error message, can't connect to server on 10.0.0.11. So we made it so that that database is actually only accessible locally on that machine. This may be a good thing or it may be a bad thing depending on how it's set up. For example, if you do need a web server sitting elsewhere to access that database, then you do need it accessible remotely. So in that case, you don't want to do this. But in this case, since we have the web server and the database on the same machine, it's okay to go ahead and do that and make it only listen locally. The best thing that you could do, even if you can't do that, is to actually change the root user password. So if you didn't know how to do that, I would just look it up, and I actually don't know how to do that off the top of my head. So change user password in MySQL. How to change a user password. Let's see. Use MySQL, and then it looks like we can say alter user, user at, and then the host name, identified by, and then the password. So if I go back here and I connect to SQL, this time I have to do it from the machine itself since I can't access it remotely. I'll just say MySQL-u root. And now I should be able to run alter user root at localhost and then identified by, and then the new password that I'll just set to ABC123. You should probably set it to a secure password, not ABC123, but just for the sake of this demo, I'll set it to ABC123. We'll see if that worked. Now I can quit. And now if I try connecting again without a password, it says access denied. But if I give it a password of ABC123, it says I'm not using a password for whatever reason. Oh, because I forgot to put a dash. Boom. Now I'm connected and I was able to log in with password ABC123. Again, if the web server that is reliant on this database is actually logging in with the root user and you change the password, that could actually break the functionality of the web application. So it's also important to look in the configuration files for the web application, find where it's actually grabbing that username and password from, and make sure that by changing that in the database, you're not going to break the way the web application works. Looking back at the common attack vectors checklist, we've pretty much covered all the ones that are worth covering. The last point I wanted to make is a lot of these protocols, like HTTP and SQL, they also have secure versions where all of the traffic passed back and forth is encrypted. In the case of HTTP, the encrypted version is HTTPS. There are a couple considerations that you have to keep in mind when working with services whose traffic is encrypted. The first thing is that as defenders, we won't be able to see the actual data that's being sent back and forth between the attacker and victim. So we'll still be able to see that traffic is being generated. We'll, for example, be able to see that HTTPS traffic being exchanged, but we won't be able to actually read the details of what is being exchanged. and that might make it more difficult for us as defenders to figure out what attackers are doing. On the flip side, attackers also won't be able to view what legitimate users are doing. So normally when traffic is unencrypted, an attacker can do exactly what we're doing, which is spin up Wireshark and monitor the network traffic, and then they can see what legitimate users are doing and potentially gain sensitive information from that. However, if the service, or if the protocol, I should say, is encrypted, then just like we can't see what is being exchanged, neither can the attacker. So there's kind of this trade-off that you have to work with. There are actually ways of stripping the encryption in HTTPS. Specifically, you need the actual encryption key that is used in the exchange that's happening. And you can actually import that key into Wireshark and you can decrypt the HTTPS traffic. This is a bit of an involved process, and I actually never did this in a cyber defense competition, so I'm not really going to be going over it here. If you're interested in learning more, you can always go to wiki.wireshark.org/TLS. TLS, sometimes called SSL because that's what the older version of TLS was, is how HTTP traffic is actually encrypted. And this page on the Wireshark wiki gives you different methods of decrypting that HTTPS traffic and viewing its contents. Again, I'm not going to go over this, and it may be too complicated for a defense competition, but I just wanted to put this out there in case you were interested and wanted to take a look. That concludes this portion of the Cyber Sandbox tutorials, where we talked about different ways of gaining initial access and how defenders can spot attackers gaining initial access, both by monitoring network traffic and by viewing service logs. Then we also took a look at how defenders can go in and fix the vulnerabilities that attackers are using to gain access.